Hello, and welcome back to our notes videos. This is the second video I'm recording. This is the video that's you're expected to watch by Friday. And the topic for this video is standard array algorithms. So coders in general, teachers everywhere, and especially the College Board have identified about 8 array algorithms, array and for loop algorithms that are very important. You'll see them again and again in projects you do, in your work, and especially particularly on the AP exam, which is why we're covering them. There's 8 of them, as I said. They're vary in difficulty. You've seen some of them before. Some of them might be new to you, but we're going to go through them one at a time, look at an example, talk about maybe modifications that you could make, talk about the difficult parts, how they work, etc. And then go on to the next one. So the 8 that we're going to cover. We got determining maximum or minimum value of an array. Then 2 that are together, determining if at least one element of an array has a particular property, or determining if all elements of an array have a particular property. We'll talk about why those go together so closely. I mean, it's partially obvious. Number 3, determine the number of elements meeting a specific criteria. 4, access consecutive pairs of elements, any operation that you would do on more than one, or I guess specifically 2 elements at a time. Determining the presence or absence of duplicate elements in an array. Shifting or rotating elements left or right, and then reversing the order of elements. So let's go. Let's start with the first one and talk through it. So the first one we're looking at is the maximum or minimum value. You've looked at this one very recently. We've done it in class a couple of times. Hopefully you're familiar with it, but I want to run through real quick. So say we want to find the maximum value of this integer array. So the big deal with this is that we have to keep track of a max variable. That's the biggest thing that we've seen so far, and that by the end is the biggest element of the array. And as I talked about in the last video, I like to initialize this to num0, to the first element in the array, to avoid any problems with weird ranges or to not make a mistake. I'm also choosing to keep track of the max index, the place where the maximum value is in the array. You don't always have to do this. Sometimes it's useful. It depends on the application, but I wanted to show it here. Our for loop is pretty standard. We're going through each of the elements one at a time. Then for each element, we check to see if nums I, if that element is bigger than the max. If it's the biggest element we've seen so far, well, then we store it in our max. And also in this case, we're going to store I, the location of the biggest one we've seen so far, into max index. Then, by the time we're done with the entire loop, we visited every element, we can be sure that max will be the biggest number, in this case 10, and max index will be the location of that biggest number, in this case 5. No, 0, 1, 2, sorry, I'm sorry, 4. That index of 10. This is something we've seen before, hopefully it's familiar, and it looks exactly the same for min. The second one I want to look at, which is sort of 2 together, is to see if one or all elements have a particular property. So the example I want to look at is determining whether nums, an integer array, contains an even number, at least one even number anywhere in the array. So here's my method. Public static boolean, we're going to return true or false. If it's true if there's at least one even number, false if there are no even numbers, at least one even, and we take as an input an array of integers, which is called nums. In my method, I've started off with an enhanced for loop for each num in nums, for every element of nums we're going to look at, and then if that element mod 2 is 0, if num is an even number, if I found an even number someplace in my array, then I'm going to return true. If not, I'm just going to go to the next number and check that one. So as soon as we find an even number, we can return true and end running our method. If we've made it through the whole for loop, we can return false, and because we know that there were no even numbers at any point. So you've seen this method before. It should be familiar with you in this kind of strategy. One thing I want to talk about briefly is what does this look like if we're trying to check if everything contains something. So what I want to look at specifically is what if I change this method not to at least one even, but to all odd. I want to write a method that returns true if every element in the array is odd, and returns false if not every, if there's some element in the array that's not odd. So take a second to yourself and think about what I would have to modify about my method to make it do this instead. If you need to pause, go ahead. I'll wait about 5 seconds. All right, so I'm hoping you've thought it through by now. If I want to change this to all odd, the only changes I have to make is I need to change this to return false, and I need to make this return false, return true. The reason this works is because all odd is the exact opposite of one or more even. If everything is odd, then that means there aren't any even, and if they're not all odd, there has to be at least one even. These are exact opposite conditions, because odd and even are exact opposites. Every number is at least even or odd. So, really, when we're doing an algorithm that wants to see if every element in an array has a specific thing, what we want to look for is to find a single element that doesn't. And if we find one that doesn't, we can return false or do whatever we're expected to do when we find one that doesn't. And then if we get to the end, we can return true. So anytime that you see this sort of thing, you got to think about the opposite, the one element has a particular property case. Let's think of an example, another example. If I want to write a for loop that determines whether every element in a string array contains, let's say, an x, well, what would I do? Well, what's the opposite of containing an x? Is not containing an x. So I really want to look for one element of my string array, one string that doesn't contain an x. And if I find that, I can return false because not all of them had an x. And if I never find one, if I get to the end of the for loop, I can return true. So really the case of all having a particular property is the same, or the opposite really, the exact opposite of one having a particular property. On to the next one, number 3. How do we determine if the number of elements meeting a specific criteria? So this is sort of a special case of the previous one where instead of seeing if all of them or none of them, we just want to count up the number that have a specific property. We saw this exactly in class on Wednesday, where with the sound problem, we want to count the number that were bigger than limit or smaller than negative limit. We wanted to count this up, and all of the cases look somewhat like that. So this example I have is count the number of strings and names, a string array, which are longer than a specified maximum length. My method header, public static, I return an int. That int is the number of strings that fit the property that are longer than max length, num2long. I have an input array of names, and I have an additional input this time, an additional parameter. The max length is the length that bigger than that is too long. So maybe I think names longer than 10 letters are too long for some particular reason. The big deal with this type thing is this count variable. I know that we've seen this before, and it's something that's key to remember, is that anytime we are checking for something, we're counting up something in an array or in a for loop, we start off with this count variable initialized to 0 outside of my for loop, and then anytime I find something inside the for loop that fits that property, or something happens, then I can increment my count variable up 1. So I used an enhanced for loop again for every name and names. It's going to go through the name one at a time. If the length of that name is bigger than the maximum length, I can increment my count variable by 1, and then I can go to the next name. So then by the end, count will be incremented. It'll be added 1 exactly once for each name that's too long, and I can return that number, just as we did for the changes for limit. Okay, number 4, accessing consecutive pairs of elements. This is where it's going to start to get a little bit tricky. So consecutive pairs of elements is anything that we might want to do with 2 elements in a row. Add them together, see if they're the same, or in this case, the example I picked is determining whether an int array is sorted in ascending order least to greatest. So it might not be obvious why this is a consecutive pairs of elements question, but one way that we can check to see if a sequence of numbers is sorted is by looking at an element and the one after it, and making sure that it is always the case that an element is smaller than or equal to the one right after it. If ever we find an element that's bigger than the one after it, that means we aren't sorted correctly in ascending order. For instance, I'll give an example down here. If we have 1, 5, 10, 8, 12, 24. 1 is smaller than 5, 5 is smaller than 10, so we're looking at 2 at a time. 10 is not smaller than 8, 10 is bigger than 8, and so then we failed to be sorted in ascending order. So we're always looking at 2 elements at a time. Let's look at the actual implementation. Public static void, I'm sorry, it should not be public static void, it should be public static boolean, is sorted, our int array of nums as an input. Then for int I equals 0, I is less than nums.length minus 1. If it's not obvious, we'll talk about this minus 1 in a second, I++. Then if nums I, if our current element is bigger than the next element, nums of I plus 1, the one right after the one we're on, then we can return false. If 10 is bigger than 8, we can return false. If we get through the whole array, and that's never true, if all of the elements are smaller than or equal to the one after it, well then our array is sorted and we can return true. So last small thing, why did I do nums.length -1 here? Well, for every element, we're also looking at the one after it. So if we went all the way to nums.length, like we usually do, we go to the last element, and when we're at 24, we'd want to check to see if 24 is smaller than the one after it. Well, there is no element after 24, so this nums I plus 1 would hit us with an array index out of bounds error. We can't check the next one for the last one because it doesn't exist, so we can't go all the way up to the last one if we're doing this consecutive parsing. This comes up all the time when you're looking at more than one element at a time. It's a very, very common error, and it's very important to realize that if you're looking at more than one, you probably have to adjust your bounds, because adding one to I or subtracting one from I or whatever it may be is very likely to cause an out of bounds error. So in this case, we had to add a -1 to our for loop. On to number 5. We're going to determine the presence or absence of duplicate elements in our array. So here's my example. We want to return true if names, a string array, contains no duplicate values, and false otherwise if there is a duplicate. For example, let's take the array of names Matt, Michael, Sam, Tino, Rowan, and Sam. In this array, there is of course a duplicate. Sam appears in the array twice, so I should return false because there's a duplicate. If I took one of the Sams out, then it would be no duplicates and we could return true. In general, the intuition for the way we're going to do this is as follows. We're going to start at an element, and we're going to go through the elements one at a time. For Matt, we're going to look at everything after Matt and to see if it matches. So our current element is Matt, then we check, is Michael Matt? No. Sam Matt? No. Is Tino Matt? No. Is Rowan Matt? No. Is Sam Matt? No. We have not yet found a duplicate. Then we move on to Michael. We do the same thing, Sam, Tino, Rowan, Sam, none of them duplicates. Then we look at Sam, Tino, Rowan, Sam. If I found a duplicate, Sam matches Sam, I can return false, there is a duplicate. If I get to the end, as usual, I can return true, I didn't find a duplicate. Hopefully you're sensing a pattern with this sort of strategy of looking through arrays. I want to point out, or I want to mention, maybe you're wondering why we only look at the ones after, why for Sam we're looking at only Tino, Rowan, and Sam. Well, Matt already checked to see if Sam was a duplicate of itself. Michael already checked to see if Sam was a duplicate of it. So we don't need to go backwards and check each pair twice. We only want to check each pair once. When you're looking at all possible pairings of elements in an array, this is a very common thing that you need to do to make your code a little bit more efficient, is only look at the ones after the one that you're currently on. And we'll see how to do that in the code. If you didn't do that, if you started from the beginning every time, it would work. It'd be a little bit slower, but it would work as long as you were careful that you didn't check it with yourself. If I'm on Michael and I check to see if if Matt's a duplicate of Michael, and then I check to see if Michael's a duplicate of Michael, and I code it wrong, my code might see that Michael's the same as itself and return false that there is a duplicate prematurely, because it doesn't make sense to count an element as matching itself. So you would need some way to deal with that if you didn't start right after. And there's various ways that you'd have to figure out on your own. Here's my method. Public static boolean, we're returning true or false, no duplicates. We take in names as an input. I have going through my standard for loop to start with through all of the elements and names. And then the first thing I do is I make a variable to store the current name I'm on. So string current name equals this current name. It'll start with Matt, then it'll be Michael, then Sam, just the one that we're currently checking for duplicates. Then I need another for loop to go through all of the names after the one I'm on. The way that I'm doing after is I'm starting J, my for loop, my inner for loop variable at I plus 1 instead of at 0. And make sure that it's I plus 1 and not I, because if it's I, we'll run into that same duplicate problem. Then J is less than names at length. We're going to the end, J plus plus. Then inside of our for loop, if current name is equal to names J, if the two names are equal, we can return false. So we found a duplicate. And as always, so after we've returned false, we'll then go and change. So instead of looking at Matt, we're looking at Michael. Then we'll check Michael, we'll check Sam, then Tino, then Rowan, and then let's say this Sam isn't here. We get done with Rowan and found no duplicates. After all of that is done, at the outside of both of our for loops, so you can return true if no duplicates were found. All right, Number 6, starting to get real tricky, shifting or rotating elements left or right. The easiest way to think of this for us is in terms of the cryptography project that we did just before break, and specifically the Caesarean cipher. In that, we are rotating letters around the alphabet, and the thing to note was that, for instance, if you had X and you had to move X 5 spots forward, it went all the way back around to, say, D or C or whatever it is. I'm too tired, I guess C. So the same thing is going to happen here with the arrays. If we're rotating the elements of an int array nums 3 spots to the left, well, the first 3 elements are going to move all the way to the end of the array, and then everything else is going to shift left to fill the space. So the array is sort of in the same spot. I guess we can maybe look at an example. If we have the array 1, 2, 3, 4, 5, and we shift it 3 to the left, well, 1, 2, 3 need to go to the end. Maybe let's make it a little bit bigger so it's a little more obvious. 6, 7. 1, 2, 3 is going to go to the end. 4, 5, 6, 7 are all going to shift 3 spots to the left, and then we have 1, 2, 3 at the end. So that's what we're looking to do. Ignore this for a second. My goal is to do rotate 3. You'll see why I have that up there in a second from a previous failed recording of this video. So my goal is to rotate 3. I don't need to return anything because I'm just changing the array as it is, and then I take as an input int array of nums. The first thing I do is I take these first 3 that are going to the end, and I store them in a temporary array that's just going to hold 1, 2, and 3. Then I'm going to take everything but 1, 2, and 3, and I'm going to move it to the left. So for int I equals 0, I is less than nums.length minus 3, I plus plus. So all the spots, the first spots that are going to hold those numbers, I make nums I whatever was 3 spots to the right of it. So I guess let me put this back for a second. That means the spot 0, we're going to put the spot 3 to the right of it, 4 there. Spot 2, we're going to put 5, 3, we're going to put 6, and 4, we're going to put 7. Then we'll have hit the nums.length minus 3. We're out of elements to move to the left, and so we're done. But at this point, our array is going to maybe look a little silly. It's going to be 4, 5, 6, 7, 5, 6, 7. Worth noting that if I hadn't stored the 1, 2, 3 somewhere, they would have been lost forever. And so I did need to store them in a temporary array, just like when we're swapping things. And then that's the reason I did it, because we overwrote those values. Now we've got to put those in the right place. So I did it manually, one line at a time. Nums, the third from the end is going to be whatever was in the first spot. The second from the end is going to be what was in the second spot. And the last one's going to be what was in the third spot. And we'll have ended up with our rotated array. So this method right here only works and is specifically designed to work with only rotating exactly 3 spots to the left. But one could imagine that one would want an element that was a little bit more a method that was a little bit more general than this. So if you have some time to think about it, maybe when you're about to fall asleep or you're on a boring bus ride or whatever, think about how you could write a method, how you can modify this method so that it rotates maybe n spots. So let's say we change this method to rotate n, where they get to pick the number of spots it rotates, and as an input, you take that number of spots. So it takes a little bit of modifying. This method isn't super easy to change. It's not super hard either, but a reasonable challenge to change so that it works for any number. So think about that on your own. You could also maybe think about how you could rotate to the right or have a method that can do both. One way that would be natural to do both is to have if n's a positive number, you rotate to the right. If n's a negative number, you rotate to the left. The more complicated, the more broad you make your method, the more challenging it is. But I think it's an interesting problem. It's a little bit outside the scope of this class. I'm not worried about you knowing it. It won't show up on the AP exam or anything like that or any of my tests. But it is an interesting problem to sort of stretch your arrays and for loop skills. All right, last one. We're getting there. I was hoping this video would be a little bit shorter than the last one, but it's not too bad. You got to listen to me for 25 minutes again, maybe. So our last one is we want to reverse the order of the elements. Lucky for you, we already saw this on a classwork today, on Wednesday in class. There's a couple ways to do it. I wanted to walk through what I think is the easiest way and then maybe talk through a couple of the other ways. Before we do that, the actual easiest way, as I know some of you guys are thinking right now, is collections.reverse. Java has this built into it. I, in general, highly recommend you using those things. There's no reason to reinvent the wheel and do things that have already been done for you. But of course, Java has a built-in way that's very similar to what we've written to do that. And it's important to know how it works, and also important to be able to do it in general so that you can write similar methods. Reverse won't always do exactly what you want, and maybe you'll need to write something that has these general ideas in it. So what do we have to do? We have a public static string array, reverse string array input, so it's going to return the array that we were reversing. Then the first thing I do is I make a new array that's going to be the reversed array. That new array is going to start off empty, but then we're going to fill it up with the elements in the correct order. And of course, it has to be the exact same size as my input array. And so I use input.length to set the size of the reversed array, and I've called it rev. Now, the next thing I have, which isn't strictly necessary, but I find much easier to understand and read and keep track of and less likely to make mistakes, is I like to keep track of the spot in my reverse array, the index in my reverse array that I'm currently adding elements to. So the first spot I'm going to put an element to 0, then when I put an element in there, I'm going to move up to 1, and I'm going to put an element there, 2, 3, 4, until we get to the end of the array. Then, since I'm starting putting elements at the beginning of my reversed array, I need to start in my original array taking elements from the end, so that we get a reversed array. So my for loop is going to go through all the elements in the input array. I'm going to start at the end at input.length -1. I'm going to go while I is greater than or equal to 0, and I'm going to subtract 1 from I every time. Oh no, I messed up my, stop. Okay, and I'm going to subtract 1 from I every time. In here, I'm going to put reverse at rev index, the current place I am in my reversed array. I'm going to put there input I. So rev index is going to be counting up from 0 to the end. If I is going to be doing the opposite, counting from the end back to 0. And I'm going to move elements from my input array into my reversed array one at a time. And then, as I said before, every time I need to put a new element in, every time I have put a new element in my reversed array, I'm going to add one to the index so that we can keep track of where the next one goes. Then once I'm done, I can just return rev. The one thing I want to note about this, the alternative way to do it that some people might do it, is instead of making a new array and putting things in there, we can change our original array by doing what's called in place without using a new array to do it. The way we're going to do that is we're going to take the first element and the last element and we're going to swap them. Then we're going to take the second element and the second to last element and swap them, and then third and third to last, etc., until those two meet in the middle and we've swapped every element with another element, except potentially the middle one if it's an odd number. So this has some advantages. One of the advantages is that it uses less space. We don't need a second array, and that might be relevant if your array is 1,000, 1,000,000, 10 trillion elements. I don't expect that to come up often, but it certainly does sometimes. Like imagine if you're taking a census of everyone in the United States, and you want to, for some reason, instead of having them sorted from A to Z, you want to sort them from Z to A, and you have to reverse that array. Well, it might make sense not to use a second array because that would be a lot of extra space to take up. In general, space is cheap, space is easy to come by, and it's not a huge concern. You're much more worried about speed, but it's not something that doesn't matter. The other advantage is that we don't run into the sort of problem that we have here, where in this case, if we want to reverse an array like, names, if I want to reverse this array, what I have to do here, in this case, is names equals reverse names, sort of like when I do s equals, s dot substring whatever, where I sort of have to save it over itself. And that's a little bit unintuitive, whereas if we did it in place, right on top of itself, all we would have to do is reverse names. I think that's a small thing, but depending on the application, depending on the user, etc., it might be a little bit, it might be preferred, it might not be. So that's all the algorithms I have to go to. Of course, let me know in class if you have any questions about anything I've covered, if you want to talk about anything more. Also, I'm still new to this, still figuring this all out, so if you have suggestions for what could make the videos easier, if you have trouble accessing them, though I guess probably if you've gotten to this point of the video, you're not having trouble with that, but just any general suggestions, I'd love to hear them. I'm just doing my best to figure this all out. Let me know if this is going well for you, and also, sort of as we get used to this, let me know if you've watched the video, because I'd love to know and make sure that everyone's on the same page. I know that maybe doesn't feel urgent to watch the videos, or we're not quizzing on them immediately. You're not directly responsible for them in class, but I do feel that it's very important to get all this material, and this is the best way to do it for you. That's it for today. Hope you enjoyed the video, and I'll see you in class tomorrow.